There is no way he's over 89.
There's no way he's gonna pick it.
Okay, we'll just try it.
And if he does pick up the phone, he's gonna hang up when you tell him to get on Google Meet.
I actually do have his number.
Do you guys all have this page open?
Yeah.
Well, Xander's making the call. So, hopefully you remember or slightly recall the area formula for a trapezoid. If it's turned this way, the height has to be the distance between the two parallel things. So this is your height. And then you have two bases. Okay. Notice, didn't answer? Okay. Notice the bases are the ones that are parallel. This, so we're, hopefully that makes sense. To find the area of a rectangle, you do base times height, because they're different lengths. You average the bases and multiply by the height. So you can think of it this way. Sometimes I just write, instead I write this. Base 1 plus base 2 over 2 times the height. I like to write it that way, okay? Now what we're gonna do is, would you take that trapezoid and when you turn it on its side? So now, where are the bases? Well, I know I labeled them. And the height is down here. So the height is along, if I was doing this on a graph, the height would be along the x-axis, and the bases would be the function values. So we're going to be putting like f of something in to find how high, and f of something in to find how high. So the same kind of formula, just understanding that this is really my y value or my function value, this is my width. Why might a trapezoid be a little better at approximating?
Because it's like curved, it's like cut off like the curve.
Yeah, like I have a curve, instead of going a rectangle or going way up too high or way too low, that angle, maybe even though it's still linear, that angle probably better approximates because it's averaging essentially those two together. So, draw a set of axes.
That seems like a pain in my
We'll just do it down here.
area.
Okay, we're going to use 4 trapezoids to approximate the area under the curve, x squared minus 2x plus 2. So we did this before, remember that? We did them with rectangles, now we're going to do it with a trapezoid. So just let's plug here. I wish it was zoomed in better, but here's 1 to 3. Would you also put tick marks halfway between, because I want 4 of them. Okay, we're going to very carefully, this is why I wish it was zoomed in a little better, we're going to very carefully draw our trapezoids. What we're going to do is we're going to see where 1 hits the graph, and we're going to see where 1.5 hits the graph, and we're going to angle that off and then draw straight down. So that's my first trapezoid. And then we're going to see where 2 hits the graph and angle that off. That's my second trapezoid. And then where 2.5 hits the graph, angle that off. And then where 3 hits the graph. Okay, what I'm hoping you can see is that is going to be better as far as an approximation goes, okay, for this particular curve. Okay, now remember our formula. We're going to average the bases together, so b1 plus b2 divided by 2 and multiply by the height. What are all the heights of these trapezoids? From here to here is 0.5. Okay, so all of our heights, remember, because the trapezoids turn sideways, are 0.5. Okay, here we go. Here's what I need from you. Do you want me to write I'm going to write out what I'm doing so you can see, okay? So what I'm doing is I'm going to do f of 1 plus f of 1.5. I'm going to average them together, and I'm going to multiply by the height of the rectangle, which is 0.5. All right, let's grab our calculators. Where's yellow? Where's my yellow calculator? Oh, here it is. Okay, remember we have this curve. So f of 1, or we can cheat from last. That's what I mean. What? What did I do? Oh, plus 2. Okay, 1 squared minus 2 is -1. -1 plus 2 is 1, right? You guys tell me what's f of 1.5. Yeah, do you guys remember from yesterday we found all these? Julia. Shh. .5625 for that first one. That's what I got. Okay, let's do the second one. We got 1.5 to 2. So we average our bases. That's going to be f of 1.5 plus f of 2 divided by 2 times 0.5. So f of 1.5 was 1.25. What's f of 2? Look at the graph though. F of 2 looks like it's 2.
Where'd you get the 6? Oh, the function.
Well, 2 squared would be 4. Minus 2 times 2 would be 0. 0 plus 2 is...
Okay, everybody makes mistakes.
So 3.25. Did you get 0.8125?
Yep.
Okay. Mrs. McDonald, do you need me while they work on this? Or no?
I was just gonna ask you a personal question,
Uh-oh.
so it's not really, no, nothing dramatic. Not today.
Okay, guys, do this one.
She wants the teacher talk about.
I'm
What
reporting.
teacher, what student are you gonna gossip about?
Oh, no, personal stuff.
Yeah.
Number 1, I haven't talked since I talked to you. Since you said I'll take the test. Yeah, but I will. This is totally personal question. Is it's just yeah, she's asking if you agree for it. Okay. Which is
51%?
No, 47.
Okay, so she's between a 3 and a 4.
Okay. All right. So, can I say?
Yeah.
Oh, that's great.
That is great.
She's gonna say.
Because she's, with no review and not done with material, she's already passed the AP exam.
Right.
Okay. All right.
Wait, I'm not done.
Oh, no.
What did you get for f of 2.5?
3.
F of 2.5 is 3?
I got 3.25.
What you get for
1.3125. Okay, last one. We do f of 2.5 plus f of 3 going into this divided by 2 times 0.5. That's 3.25 plus 6, right? Is it 6?
Plus
5. silly. Divided by 2 times 0.5. So that's 8.25 divided by 2 times 0.5. I got 2.0625. Okay. Now let's do our area under the curve is approximately, let's add them together. I got 4.75. Can somebody confirm? Okay.
Yeah.
Is the area under the curve. By the way, the trapezoid rule connects the left and right endpoints with a segment. This method approximately turns out to be pretty good, but if you were to connect the endpoints with a curve, a parabola, that would be even better. Connecting the endpoints with a parabola and finding the area is based on the fifth method, which is called Simpson's rule. You might see it when we do some problems in your textbook. Simpson's rule is not something we cover in AP Calc, but just exposing you to knowing that if you were to take Calc in college, they might talk about it. It is another way of approximating, but we're going to only do rectangles, so left, right, midpoint, and trapezoids.
This seems very tedious.
So it is, but when I assigned your homework, did I have you do too much tedious stuff? I think this process of knowing what we're doing is important because then we know different ways to find F. We had an equation here. The likelihood of you really doing a trapezoid approximation with a difficult equation like this is very low. More likely, you would do one with a table, such as the oil problem. Remember the oil problem? Or like the table that with just 3 intervals. That's how it would more likely be assessed on your AP exam. We should talk about concavity though in the trapezoid rule. Remember how I said with rectangles you can tell, and I don't like to memorize things. I just kind of like to sketch a picture. If a function's increasing, where can I draw this? If a function's increasing, and I was doing, of these intervals, I was doing a left-hand approximation, do you see how that would underestimate? Okay. What if I were to do a right-hand approximation? Xander, you should put that away now that we're not talking with him. He's up now? No? Okay. Then it would be an overestimation, okay? With rectangles, that's all you have to look at is increasing or decreasing. With a trapezoid, it's kind of hard to see here. It has to do with concavity. I'm going to really overemphasize. This is something that's concave down, right? Okay.
What is?
Oh, concave up, sorry. Concave up. Thanks, Julia. Let's say I was to break this into some trapezoids, concave up. That's hard to see, but you can see now. Do you see how that goes a little bit over? Oh, sorry. Concave up. Do you see how concave up, the trapezoids go slightly over the curve? Slightly over the curve?
Yeah.
Okay. If the interval was concave down, then trapezoids would be slightly below the curve.
So concave down is an underestimate. Concave up is over.
So trapezoids don't have to do with increasing and decreasing. They're the only approximation that has to do with concavity. If that makes sense. Did you guys have a question? No?
Where does some people go in?